Welcome back. In this part, we will create this skeleton and bones simulation. So they look like they've just been fallen and laid out in a very organic way. So before we get into that, I wanted to talk a little bit about the camera for the scene and the importance of setting up the camera before we do anything else, because we can basically depending on the camera we can put the skeleton behind the pumpkin, or we can completely change the position of everything. So it's a good idea to start looking at this as a more or less final shot. So I'm going to click on the no cam right on top of the viewport and then use new camera, and then I am going to put exactly the same numbers from the camera. And actually, you know what, just to save time, I'm going to copy the camera from my scene here, and you can just make sure that the numbers are exactly like that. And if I go now to camera 1 and if I go inside of the Halloween, you can see that the camera is going to match what I have here. Okay, so from here we can now decide where we want the skeleton to fall. So logically, the pumpkin takes the left third of the screen, and then the skeleton will be somewhere around here. So that made more sense for me, so that's why I put it in here. So let's see how we can actually first achieve to extract the skeleton from the base geometry. So in Houdini 21, you have a new character. It's called Auto. So if you press tab and type Auto, this is a great asset that has a full male body with the muscles. Let me actually just turn off the pumpkin. So it has all the muscles inside. It has the skeleton. It has all the realistic materials and everything else set up. So we will be using this, and you would see that if I select the auto, it will have 3 outputs. We are interested in the geometry output, so if you press null, you would see that it has the geometry. The second one is just a static skeleton rig, and then the third one is for animated pose. So we are focusing on the first output, and in the auto asset itself, you can actually only turn on or off specific elements. Okay, so you can see that right now the output set to skin surface, but you can set it to all geometry, and then this will give you access to different kind of layers. We don't need any proxy geometry, we don't need simulation geometry. We're just going to take the render geometry. I'm going to turn off the skin, turn off fingernails, turn off eyes. I'm going to keep the mouth, and I'm going to also turn off the organs. But you can also maybe do something with the organs. Since this is Halloween, you can maybe do a soft body vellum. I'm going to leave it to you. So mouth and skeleton, this is what we have, and also teeth. Okay, so from here I'm going to put down group delete, and we basically want to simulate it in a way that the skull is going to be the basically the most visible part, and the bones would be just like randomly scattered around. Depending on your simulation settings, every time you do an RBD sim on this, it might look a bit different, but I was able to make sure that the skull would always land in this position, and I'm going to show you how exactly I did that. So before we move on, let's delete all the unnecessary groups. I'm going to do group delete because there are a lot of groups here that just keep on flowing down. So let's turn on delete unused groups, and then I'm going to split the mouth and the skull and the mandible geometry, because If I do an exploded view on this, you would see that everything is pretty much separate, but I want the mandible, the teeth, and the actual skull to be almost kind of glued and merged together as one mesh. So when we do an RBD sim, the lower jaw doesn't just fly out and we don't end up with the top of the skull without the teeth. But of course, if you want, you can do that. I'm just showing you my workflow, how I did this, right? You can completely skip this part. So let's do a split node. So I'm gonna do split, and you can actually see a lot of the data that comes with the skeleton. If you select the node before split, and then if you go to primitives, you would see that there is this path attribute that has the path to the mouth, geometry, to the teeth, to the skull, and just setting up the correct name can give you access to those specific elements. All right. What you can do basically in the split, you can provide an expression to a specific path. So for example, if I click here, there's a lot of things, right? But I can just say, okay, so maybe I want, let's just choose this teeth one, right? So you can see that if I split this, it will only give me the teeth, but I want everything that is under mouth, right? So if I just delete this teeth, and if I put star there, it will give me everything that comes with the mouth, right? So this is going to be the process of splitting things up and then combining them back together. Let's delete these. Okay, so we splitting up the teeth, and then we will split the skull and the mandible, and let's just do another split. And if you know that there is something called skull and if there's something called mandible, you can also use wildcards. So you can put something like this in the group. So you can say at path equal to star, skull, star. It will just choose everything that has skull name in it, and then same for the mandible, and there's just a space between them. So now you can see I have successfully isolated just this skull and the mandible, right? And then we can merge them together. Okay, we can merge these two. So there is one thing about the topology. So if I look at the topology, actually wireframe, you can see that the teeth are very detailed, and the skull is actually not that detailed. And to combine the two of these, I will need to use VDB from polygons, right? So if I do VDB from polygons, and if I use a lower resolution, something like 0.001, this is what happens. But I don't want to see these squares from the low resolution skull topology, right? Because the VDB would just, at certain resolution, it would just take the exact squares like that. So we will need to subdivide just the skull and the mandible, right? So I'm going to convert them to polygons because right now they are packed. So we'll convert this, we'll subdivide this. Okay. And now we will have a much nicer VDB. Cool. So after this, these would be merged together. Even though we don't see it, they will be merged. And we will do convert VDB into polygons. There we go. And in the convert VDB, you can use some adaptivity. I actually used quite a bit of adaptivity because I didn't need a very high-res skull for this. And then there are going to be some weird parts in there left over of the tongue maybe, or something else. You can use labs, delete small parts to get rid of that. and there we go. So labs delete small parts, we can just say extract the largest piece, and that should be it. Okay, so we got now the head with teeth separated. There is an important part here where we will need to transfer the path and UV attribute back onto this, otherwise we wouldn't be able to split it out based on the name, or we wouldn't be able to use UVs. So let's just do it while we're here. So attribute transfer. So we will just transfer attribute from here here, and we just need to transfer the path and turn on vertices and transfer the UVs. There we go. And then we will basically transform this skull in a position. So if you look at this all together, the skull is really on the top. And if I would do an RBD simulation, as a matter of fact, let me show you what is going to happen and then why we are doing things that we are doing. Let's just merge these together. So we're going to merge these two, and then we are going to run it through the RBD configure to create name and prepare these to be packed fragments for RBD simulation. So RBD configure. So we'll use RBD configure here, and in the RBD configure we can just say that you know, everything is default. We don't really want to change anything. So let's just do a simple bullet simulation. So bullet RBD bullet solver. So we only have the high-res geo. We don't have any constraints. And let's just give it collision ground plane, and let's simulate. Press play. Okay, I'm gonna turn off velocities. Okay, so everything is just going to fall down, and no matter how much you try, the skull would just fall down and start rolling back or forward. It's just going to be really hard to control it to land and sit still like that. So that's why we're going to cheat it a little bit. We're going to give it a starting position. I'm going to put a transform node, and basically I have very specific values in the transform node. In order to save time, I'm just gonna show you what they look like and where the skull would end up. So this is the transform node. You can just copy these values and you would see that the skull is pretty much even like less than a centimeter away from falling down and ending up in this position. So we are pretty much transferring the skull pretty much to the desired position, so it will fall down and just settle, and that's gonna be it, right? So if I now play the simulation, you would see that boom. So it sits down and then everything kind of collides around it, and it will create this kind of nice effect. All right, so there is another thing that I did that you can also do. I deleted the spine. I didn't really need the spine, and I also did something to the pelvis, which I think you also wouldn't need to do necessarily, but if you really want to follow along and make this look closer, this is what we can do. So after splitting this from that, we can just use blast node. I'm going to blast the spine. So this part is the body. So if I just turn off the blast, you would see that it has everything but the skull. So I'm just gonna say here blast at path equal to star, so shift 8, and if I just type SPIN, so everything that has these 4 letters in it, and I know the spine is actually called spine, otherwise you'll have to check the letters, it will delete the spine. Okay, because I didn't really need the spine. And then what I did to the other stuff, let's put a transform node to oh, actually, you know what? I think I separated the pelvis and the rib cage first. So yeah, let's do split, another split. Again, this is completely custom. You don't really have to do this. You can only keep what you need. So in the group, I splitted the rib cage and the pelvis from the spine. So you can say at path equal to star rib, right? If you want some ribs, and then at path with the space equal to star pelv or pelvis. Okay, so it will separate the rib cage and the pelvis from the spine, and then here actually we can just transform them. Maybe actually so we can just transform them a little bit. That is actually a bit strange, but let me see. Yes, so we need to invert the selection. There we go. So now we can move the rib cage and the pelvis a little bit back. Again, I did it for specific reasons. You don't really have to do it. Minus 0.25, and let's merge them together. Okay, so this will give us something that looks more like that. So I simulated 96 frames to settle, and for the bullet I'm using slightly modified settings for better collisions. So if you go to the bullet solver, first of all, in the setup I'm using 25 substeps because it's a fast simulation. I just wanted to have more substeps because there are a lot of small parts in there. And then also in the collision geometry, I reduced the padding by 8 times. So the padding is basically the proxy geometry that would be created around the original mesh, and this decides how tight it will be created. So 0.002 is designed for bigger scale objects like buildings, but for smaller scale I usually reduce it to a much smaller value. The other thing I did, I turned off the bounds completely, both from the fragments and also in the collision. So basically all the collision would have 0 bounds, and also the ground would have 0 bounds. I didn't want things to bounce up and down. So let's take a look now. So yeah, this will give us a bit more rigid kind of simulation, and it will actually create some nice areas where the rib cage would land onto the skull. And if we go to frame 96, it will look still a bit different from this, because I believe for this one I didn't even do so much separation on the skeleton. I deleted a lot of parts because I didn't like how they were intersecting with the candle silhouette. So your result might look a little bit different, but you know the techniques now and you can definitely see where they are. So this is all simulated in the center of the world, and if we want to take the specific frame from it, we can just do time shift, put it here, and we can just right click, delete channels, and have frame 96 frozen. Okay, so after this we can put a series of transformations to put it in place. So if we go to camera 1, we can put down a transform node, and it would be handy to preview the candles as well, how they are and where they are. You can see the candles are still quite big, and I wanted to make sure that the skeleton is going to be more or less realistic size, so I scaled it up by 2.5. Also, I have translated it 1.5 units, 1.5, 1.1, and then 0.5 here, and then I have rotated it minus 64.4 degrees. Okay, so this was the base. I think after this I have done some manipulations to the parts, but mainly what you really want to do is you want to delete everything around this skeleton. You don't want all these small tiny parts to be around it, because we will be converting this into the VDB, and having VDB from here to here would make a huge difference compared to if you just concentrate it to a smaller area. And we will need to convert this to VDB to get more interesting kind of details. Well, if we need to do that. Otherwise, it's also a good practice to just delete the things that you don't need, right? So we can do it quite easily. We can just unpack the pieces. Unpack. And then we can say that I want to blast the skull and the mandible again. So it's going to be this pattern, and delete non-selected. So everything around the skull we want to keep. So we can use the bound node. Okay, and I'm gonna use a sphere, and let's see. So that's our skull. Let's template the bound. So in the bound we can just do something, I think a value of 1 in everywhere was good. So let's select this, Control C, and then paste relative reference everywhere. Oops. Okay, paste relative reference, paste relative reference, just so we have control. So now you can see that you can control it. Accurate bounds sometimes can give you a more accurate result. Okay, so we set it to 1, and then what we do with that, this is just for this part. We will use group, and we're just going to do group points, because these are unpacked points. And I'm going to turn off base. I'm going to turn on group by bounding object, which is the sphere, and everything inside of this group will be now in this group. We can choose keep, and then we'll just blast everything that is not keep, so we can have a cleaner result. So everything but just to keep, and delete non-selected. So we have a very clean result now. Okay, so from here, what I did, if we go to the camera and then if we preview everything again, so Control Shift click to the template here and here, I deleted a lot of the bones that were intersecting with the pumpkin. So you can literally just select this blast, and then you can go to the viewport, press S, and you can start selecting those bones, first of all, that are intersecting with the pumpkin, and then the bones that are kind of in the front, like if you go from the camera view. So I didn't want to obstruct the view of the skeleton, so I selected those bones, and then you can press delete. It will blast them out. Okay, and then you can also edit some of these bones to look to be in a specific way. I actually want to delete this bone as well, and maybe something in the back. You know what, I'm just going to copy the blast that I had, but you got the idea, right? So you can just keep that. So that was yeah, I'm just gonna call this keep. Oh, this was not keep. Oh, that was a selection. Sorry. I'm just gonna select this selection. Yeah, so you can see basically what was kept. Maybe it's actually not that accurate. Okay, let's just do it here. So I'm going to click on that and keep selecting things that I want, that I don't want. I don't want to have that. I don't want to have this. And that's, again, that's basically being decided by what I want to have behind the candles and in front. Okay, so let's say we have something like that, and then additionally, like I mentioned before, you can take certain elements and then you can move them to a more kind of desired location. So for example, after this blast, you can press S, select this bone, press T, and then we can move it forward. And then if you press R, it will change the rotation. All right, so we can just kind of direct and place things where we want them, and we can go back to the camera angle and we can decide, okay, so maybe this is good here. Okay, so that kind of looks cool, and you can see this is kind of what I did here. All right, so definitely play with this one. So this is all good, and basically I'm going to wrap it up here because we will be adding a little bit more details to this skeleton once we get into the rendering part, and I'll show you exactly what we did there. But as far as the skeleton and all the objects laid out in our scene, this is what we have, and this is now ready to go into look development in Solaris. Okay, I'll see you in the next part.